Hello everyone, welcome back to the channel. I hope you guys are doing amazing. Welcome to the seventh video of DP series in this playlist, and this is our second video on DP of grids. And this we will in this video we will study another important pattern of DP on grids. The last video we studied a pattern. Okay, the last pattern was DP on grids only, but it was of the type to count the number of paths, count number of paths in grid. Okay, so if you want to reach from a start point to end point, if you want to count the number of paths, with or without obstacle, if you have some obstacle or if you don't have any. So I talked about two lead code problems, unique paths. I hope you have already solved that. And in this video, we will learn how to do another pattern, which is find the minimum path. Okay, finding minimum path. So in this pattern, we will not count the number of paths, rather find the minimum path, which gives the find the path which gives the minimum cost. Okay, with respect to cost. So how the problem statement will be? Let's try to discuss. Let's try to see this first problem. Okay. So both problems are pretty similar. So let's see what the problem statement says. Minimum path sum. We are given an m cross n grid filled with non-negative numbers. Find a path from top left to bottom right. So you need to traverse from this top left 0, 0 to m minus 1, n minus 1, which minimizes the sum of all numbers along its path. You can only move down or right at any point. Okay. So if you want to reach from this to this, it's given that you need to traverse from 1 to 3, then 1, and then 1, and then 1. Because if you sum all these paths, 1 plus 3 plus 1 plus 1 plus 1, this is 7. Okay, and you need to output 7. So what would have happened if you had taken some other paths, like after 1, let's say you go to 3, then you go to 5, and then you go to 1, then 1. So then you can obviously see that the path sum will be 1 plus 3 plus 5 plus 1 plus 1, which is much greater than 7. It is 11. Okay, so it's much greater than 7. So you can understand that that is not optimal. That is not optimal. Okay, so you want to approach in a DP manner. Okay, so you want to approach this problem. So let's see how can you do it. How can you do it? So first of all, you can see this is very similar to that unique paths problem. All you need to do is count the number of paths there and see what is the value of the path in this case. Okay, so if you are at an index I comma j, let's say, if you are at an index I comma j, you know that you can move always to the right and to the down. Okay, so if you want to reach this point, you have either moved this down or either you have moved from this cell. Okay, so this cell was nothing but I minus 1 comma j, right? This cell was nothing but I minus 1 comma j, and this cell was nothing but I j minus 1. So if you try to think, as I had already told you that you should, in this grid problem, you should not think about recursion memoization. Okay, you should not think we do recursion memoization and tabulation. You should try to skip these steps and directly go to the tabulation method. So and you must think backwards. You must think backwards. So as I have already told you, if you want to reach ij, you have two ways. Okay, from this you can reach, or from this. So what can you do? What can you do now is that let dpij, you can tell that, let dpij denote, okay, uh, path to reach, path sum, minimum path sum. Okay, minimum path sum to reach I comma j, to reach I comma j from 0 comma 0. Okay, okay. So if you see, this P is giving you the minimum path to reach from 0 comma 0 to this cell. Okay, and it is also giving you to reach this cell, and reach this cell you have two choices. So what is the minimum for this? What is the minimum path for this, given that you are given these values and these values they are given? So what is the minimum path to reach this? So my question is that what will be the dpij? Can you tell me what will be dpij? It will be nothing but plus equals to the value at this cell is this cell. The value at this cell is nothing but dpij, let's say. Okay. uh, or let's say it is given in some grid array. It's given in some grid array. So I take the same grid array. Okay, no problem with that. Plus you do minimum among these two elements. Okay, minimum among either this or this. So you take the minimum among dp I minus 1 j or dp j I minus 1. So I hope you understand this easily. If you have seen my unique paths video, then this is very trivial and very easy also to understand. Okay, so there is not at all any difficulty in this. So if you are reaching this in dp, this gives you the path to reach from 0 comma 0 to I minus 1, and this gives you the path to reach from 0 comma 0 to j I minus 1 and I minus 1 j. So whichever is the minimum, you will take that path in traversing from that cell to this cell. Okay, so in order to reach the I comma j from 0 comma 0, this will be your answer. Okay, this will be your answer. And if you try to think, let's say you are having 3 cross 3 grid. Okay, let's say you are having a 3 cross 3 grid. So the grid can be much bigger also, but assume that you are having a 3 cross 3 grid now, and you want to move from this cell, and you want to see that what is the minimum cost to reach this. Do you have any other choice to, let's say you want to reach here, do you have any other choice than this? Do you have any other path? You might be thinking that let's go like this. Okay, but that is not possible, right? This path is prohibited. You can only move downward and right. So if you are given to move only downward and right, if you move downward once, you cannot move upward then again. Okay, so if you want to reach there, you have only one choice. So let's say if you are given a very big grid and you want to reach it at any point, then you have only one path. Similarly, this also you have only one path. So this is very similar to that count paths. Here you are just adding up the value, but this gives you the idea of what is the base case. Okay, so with this will be the base case, and we will start filling up a table, dp table from these cells. Okay, as we will use this I minus 1 j and j I minus 1 cells also. In creating that, first we need to fill these base cases first. Okay, so I think you understand this easily. So let me just go through this. Okay, let me just go through the coding. I will not create a separate dp table. I will assume this grid is my dp table itself. Okay, so that I am doing. So what will you do now? You now need to know which is the n and m. Okay, so let's say grid dot size is m. Okay, let's say this is m, and let's say this is n. Grid of 0 dot size. Okay, so m rows and n columns. I'm taking m rows and n columns. So as I told you, I am just now going through the, let's say, the first column. Okay, the first column only I am going through that. So what will I do? It's very simple. We will go from I equals to 0 to I equals to m, not 0, 1. Why I am telling you? And I plus plus. So what will I do here? I will do grid of I, the first row, and the second dimension is 0, because this is the first element of every row, right? The second dimension is 0. This is nothing but dpi plus equals to grid I minus 1 of 0. I hope you understand this, right? You started from 1 because 0, this 0 comma 0 is already filled. You are already standing there, so minimum path to reach is given already. Okay, so this is nothing but 2. Okay, then this will be nothing but 6. So how exactly is this happening? I will just show you. 131 151 421. Okay, so I will just show you in some other page. So what I am doing exactly, if you are getting confused by any means, that's why I'm just clarifying my approach. So you are given a 3 cross 3 table like this. Okay, so how exactly are you updating your values? Okay, so what you are doing is that What are the values? 131, 151, 421. You are given the values 131, 151, 421, and you want to reach from this cell to this cell. So what is the minimum value to reach from this path to this path? It's 3 plus 1, right? 4. So what do I do here is very simple, is that I rub this 3, and do 3 plus 1. I just add the previous value, it becomes 4. This one, I rub this 1 and I write the previous value, which is 5. Add with the previous value. Similarly, I keep adding this to get 2 here. Okay, I add with my top portion, because in order to reach this, you can only move down. And this one, I remove to get 6. Okay, 4 plus 2. So this way, we handle the base cases. And now this 5, when it comes to 5, if you want to reach this cell from 0, 0, you can either move from top or move from down. Which is the minimum value reach? It's 2 or 4. Okay, so 2 is the minimum value. 2 plus 5, it becomes 7. So remove this 5 and becomes 7. Okay, so similarly, you approaches this 2 should be added with 6, because 7 is is greater than 6. So it's okay. I guess you understand this. This becomes 6, and if you see, this becomes 7. So this, our answer was 7. If you remember, our answer was 7. So how it is becoming that we, in order to reach this, we choose the top portion. Okay. So it goes as like, if you want to reach this, you choose this top cell. Okay, because it is having 6 and this is having 8. Now, in order to reach this 6, you choose this top cell, because it was having 5 and 7. So 5 is minimum. And in order to reach 5, you have no other choice but to reach this and this. So that's the minimum answer. That's the minimum value which I am doing. Okay, so that's how you will get it. So that's what I'm doing for all the rows. For all the rows, I'm just adding my previous value. Adding my previous value for all the rows in the first column. Okay. So now I will go through nothing but the size of n. Okay, and it will be simple. Grid of 0. Now everything is in the first row, so the first dimension is 0, and I will do the exact same thing. Which I did. Again, I minus 1. I will add the previous value. So these are the base cases which I handled. Okay, I guess you do understand it now. Okay, so what do I do now? It's very simple. I start from I equals to 1, and I go till m. And I also start from j equals to 1. And I go till jn. Okay. And what do? I do that dp value. Okay, so whatever transition that we derived, dp grid ij is nothing but plus equals to minimum value of grid. Either you can reach from the upper cell, which is Reynolds I minus 1 comma j, or you can reach from ij minus 1, from the cell which is behind me, just left of me. Okay, so either you can reach from the upper cell or from the left cell. So you just select whichever is the minimum value. You just keep adding m and n, and as you say, grid ij denotes, okay, grid ij is acting as dp. So grid ij is acting nothing as dpij now. Okay, so it shows nothing but minimum path, minimum cost to reach 0, 0, to reach I comma j from 0, 0. Okay, so if you want to reach I comma j from 0, 0, so what do you want to reach now is that you want to reach m minus 1 comma n minus 1. You want to reach the last cell. So that will be given by this grid value. And if you try to submit this and check, I think it will be all right. So you see, we have the accepted thing. If you try to submit it, yeah, we have the accepted thing. Since I did not create another DP array, so it gave me a very good memory runtime also, apart from this thing. Okay, so now we'll see this question, which is very similar to this question. So you should definitely try on your own. The thing which is different is that only the shape is different. So you are asked to traverse from the first cell to the last cell in a square grid, in a rectangle grid, I would say. and here you are asked to reach the top row to the bottom row, and you want to reach the find the minimum path sum, and the shape is triangle. The shape is triangle. Okay, so let's understand how will you do this. And if you see the question, you need to return the minimum path sum from top to bottom, and if you are at index I, you may move either to index I or I plus 1 in the next row. So what does this mean? Let's see. Let's try to copy this example and understand this question. So I will take this screen, and this is the second question, which is the triangle one. Okay, so what are the values which are given? 2, 3, 4, 6, 5, 7, 4, 1, 8, 3. 2, 3, 4, 6, 5, 7, and it's 4, 1, 8, 3. So it's 4, 1, 8, 3. So I guess you already understood. Let me just rub this out. So you want to, if you are at this cell, you can move only to the cell, which is, if this is I, okay, you can move only to I in the below cell or I plus 1. Okay. So from 5, you can move to 4, you can move to 5 or 7. From 7, you can move to 8 or 3. From 5, you can move to 1 or 8. You cannot move anything else. You cannot go for anything else. Okay. So I hope you understand that this is very similar to the square problem also. So you see the length of this is, let's say I, let's say it goes from 0 to n minus 1, and I is of length n. You see length of this ith value, if this is ith row, the length of the ith row is also I. Okay, so this is the third row and the length is also 3. So if the index number is I, the length will be given by I plus 1. I hope these kinds of observation you can easily make. And if you see, if you want to, you have, you what are your starting points? What is your starting point? This two. And what are your destinations? This 4, 1, 8, 3. There are 4 possible destinations. Okay, so now from you can move all the way to 4 also. If I ask you what is the minimum path to reach 4, you can say that I can move 2 to 3, 3 to 6, 6 to 4, and my path sum will be nothing but, if you try to think, 2 plus 3 plus 6 plus 4, which will give me 13. If I ask you, can you minimize anything more? You will say that if I go from 2 to 4, I'm moving from I plus 1, and then again from 4, I cannot move any back. I can only go straight or right? I can only go from straight or right. So there is no way, if I move right, I can move left in the next iteration or in some further iteration. There is no way I can move left. So if I want to reach 4, this is the only path. And similarly, if I want to reach the last element, this is the only path. If I move down, I cannot move 2 steps right again in one iteration. So if you want to reach the first element or last element, these will be our base cases, because they have only one choices to reach them. Okay. So again, this triangle array, we will denote that this triangle IJ gives that a minimum path sum from 0, 0 to I, j. Okay. So if you see the first value, it is given in the question that the first uh, row will always have one element, the second row will always have two elements, third row will always have three elements, and so on. This criteria will not get violated. So see, if you think of 5, you have two possible choices. It can come from 4 or it can come from 3. So minimum among those. So similarly, we can create a DP first of all. We can create a DP in a very similar manner. So I write 2 here. Then this is nothing but 2 plus 3, 5. Because in order to reach 3, there is only one choice. In order to reach 6, there is only one choice. From the top only you can reach. I just now discussed this. And from 4, you have only one path. So you see, if you try to reach this, this was 15, right? This was 15. So you see, you have only one choice, 15. Okay. Now, if you want to reach 4, if you have only one choice, you can go from 2. So now, if you want to reach 7, you again have one choice. You can go from 2 to 4 to 7. So that's 6 plus 7, 13. Okay. And if you want to reach 3, you have a dash here. So it's a blank. And these have 2 blank places. And if you want to reach 3, you can add just 3 to 13. That's the only way. Okay. But if you want to reach this cell, this particular cell, if you want to reach, okay, this particular cell, if you want to reach, you have two choices. You can come from 6 or you can come from 5. So whichever is the minimum, you will just take that. So I will take minimum among 5 and 6, and I will add that to my current cell, which is 5. So minimum among 5 and 6 is 5. So I will add that to get 10. So I get a 10 here. As you can understand, I get a 10 here. And so again, this cell, if you talk of this cell, it can come either from 10 or 15, and it itself has a value of 1. So obviously the minimum among 10 and 15 plus 1 will give me 11, because minimum is 10, so it has 11. And so if you want to reach from, if you want to reach this cell now, you can either reach it from 10 or 13. Obviously 10 is the minimum, so I will take 10, and the cell itself is having a value of 8. I will add 18. So I guess you already understood, right? Then you just traverse this last row and take whichever is the minimum. The minimum value was nothing but 11. You see, minimum value was nothing but 11, and this will give me my answer. So I hope you understood the entire approach. The minimum output, you say it's 11. So similar things, it is very similar to this minimum path sum. So what you need to do is write the base cases first. So you go ahead and write the base cases, the first row and the first last element. Okay, the of every row, the first element and the last element are the base cases. So the thing is that the dimension is only one dimension, because n I can only extract, otherwise value is changing every time. And then what I can do is that for the first cell, I can go all the way, okay, and the first element, I can just the triangle of this first element, okay, not the first, the ith element, ith row, and the first value. This I can add, this I can always add to be triangle of I minus 1, 0. Same thing as I talked about. Same thing as I talked about. I am just adding the previous value. And also you see, last is what? Last is what? Did you understand this? The last thing. What is, if this is the, what is the last value? This is, let's say, triangle of 0, 0, right? This is triangle of 0, 0. And this 6, if I try to initialize, I'm trying to find the index of this 6. This is nothing but triangle of 1, 1. You go to the first row and you go to the second element. Okay. Second row and second element. So this is nothing again but triangle of 2, 2. So similarly, you see these indices are same. How to recognize the last element? The indices must be same. And if it's I, if the index is I, okay, it will be I only. So you try to say it's I. So you need to update the last element also as our base case. That is nothing but triangle of I minus 1, I minus 1. So you are just adding this previous value. Okay. I guess you understood this. If you did not, just try to see it once again. Try to see it once again. That uh, you are adding, first of all, this 4, you are, in order to get this 7, you are adding plus 4 plus 7. 7 is nothing but triangle of 2, 2. So you are adding the previous value, 6 plus 7. So you are adding I minus 1, I minus 1. Okay. So I guess you understood this. There's not much difficulty here. So you are done with the base cases. So what you see, you start from the first element will always be something one length, and their next element will be 2 length. So third row is only which you need to fill, right? Start filling from the 5. As you see, this is the dash. Otherwise, all other were already filled. The all others are already filled. So I will start from int I equals to 2. Okay, and I will go all the way till n. Okay. I started from the second to third row, which is given by the index 2, and it's very simple. Okay, I guess you understood this. So what I will do now is that I will start from index 1. I will have another iterator j. Okay, I will start this from index 1 because the first element is already filled. This 0 is already filled, and till what I need to go. J value is having a length of I. I don't need last value, so I will just go till I minus 1 and j plus plus. I hope you understood this. Now, triangle of ij. What is triangle of ij? As I told you, I will add nothing but minimum among my previous two values, upper two values. Okay. So what is the upper value? I minus 1 j. Okay. Or it will lie in the same I. Okay, or it will lie in the same I. Pick whichever is the minimum and just go ahead and fill it. And at the end, you need to iterate through the last row. You need to iterate through the last row to get the minimum value, right? So you just iterate through the last row for auto x. Not don't do auto x. Let's try to understand and write. So for the last row is of length n only. Okay, and the last row is n minus 1. So answer equals to minimum of answer comma triangle of n minus 1, and it shows the ith value. From n minus 1 it shows the ith value. So we just return answer. I hope you understood this. We just filled all the dp values in this triangle only, and we are just returning the last value. Okay, let's try to run it. Minimum among the last row we are just returning because those are our possible endpoints. So we do get a wrong answer. So let's try to see where our error is. So these are the base cases which I assigned, and this is nothing but starting from I equals to 2 I plus plus, and this starts from j equals to 1 and goes all the way till I minus 1, I minus 1, and triangle of ij is nothing but minimum among the triangle of I minus 1, okay, and j, and triangle of ij, not triangle of ij. Okay, so there is a mistake here. You can understand that. Uh, this is nothing but I minus 1 is always happening, right? The previous row, we are deriving the value of the current row from the previous row. So that should always be I minus 1, and it should be between j minus 1 and j. Okay. So if you did not understand this, let me try to tell you. You are having a triangle like this. Okay. This element, let's say, is I comma j. Okay. I comma j. These all values are I minus 1, right? So it can come from this, which will imply that it is coming from I minus 1 comma j, and it can come from this also, which will imply that it is coming from I minus 1 j minus 1. Okay, so you see it's coming from I minus 1 j minus 1. That's what you need to do. Let's try to run it now. So you see we have the accepted case. Let's try to submit it and check if there is any further error or not. So you see we have the accepted and a pretty good runtime complexity also. And now I will suggest you to do this question on your own. It is a very similar problem as I have done. It is rather easier than this triangle problem also, because you don't need to think so much about these indices values. This is much more simple. So I will tell you to write this solution in the comment section in whichever language you do. So this will be all for today's video. I guess DP on grids. We may do a one more video of DP on grids. Okay, one more video maybe we will do, and then we will move to the DP on strings. Okay, we will move through the DP on strings, and we will visit some important problem patterns. So that was all. That was all for this video. I will meet you in the next video. Thank you so much.